This video is going to cover Chapter 7, Section 5, Operations with Matrices. So now we know what a matrix is, and we've learned how to use them to solve a system. We're also going to learn all the other things that you can do with a matrix. The first being defining the equality of two matrices. So two matrices, A and B, are equal if and only if they have the same order, which is the dimensions, number of rows by number of columns, and that each element in the matrix is also equal. So if A was equal to B in this example here, if matrix A is equal to matrix B, then each element in A would match each element in B. So X would equal 1, Y would equal 5, or Y plus 1, sorry, would equal 5, making Y 4. Z would equal 3. And then obviously the last one is 6 equals 6. So no matter if it's a 2 by 2 or a 2 by 3, it would also match a 2 by 3. And then each individual element inside that, in the order that it is, would also be equal. Example 1 just says, find the value of X and Y that makes the matrices equal. So if these two matrices are equal, then 4 would equal 4, which it does. 3 would equal Y minus 2. Which makes Y 5. X plus 1 would equal 8, which makes X 7. And then 7 is 7, so that one's already taken care of. Sum and differences of matrices. So you can add and subtract matrices by adding or subtracting the corresponding entries. You can only perform addition or subtraction if the matrices have the same dimensions. So you can only add a 2 by 2 to a 2 by 2, a 3 by 2 to a 3 by 2. You cannot add something like a 2 by 3 or a 2 by 2 to a 2 by 3. So if you had something like 1, 2, 3, 4, which is a 2 by 2, and then 1, 2, 3, 4, 5, 6, a 2 by 3, this would match with this with this, but then there's actually no third column here to add to it. So hopefully you catch yourself in a case like this, but in order to check, you cannot add them if they have different dimensions. Example 2 says, carry out each indicated operation or explain why it can't be performed. So the first thing you want to do is compare the two matrices involved and make sure they have the same dimensions. If you look at A, you've got two 2 by 2 matrices, so this can be done, and the sign in between is the plus. So I'm going to take the 2 in the top left corner, row 1, column 1, and add it to the 5 in the second one, and I'd get 7, and then 3, row 1, column 2, and negative 1, add those, and I'd get 2, negative 4, row 2, column 1, and 7, row 2, column 1, negative 4 plus 7 would be 3. And the last one, 6 and 0. So the resultant matrix should have the same dimensions as your original matrix, which would be a 2 by 2. Looking at B, you're also doing a 2 by 2, so you can do this. Negative 6, this time minus. So negative 6 minus 7 is negative 13. Negative 3 minus 10 is negative 13. 10 minus negative 3 becomes 10 plus 3, or 13. And 4 minus 8 is negative 4. C, this is a 2 by 3 and a 2 by 2, so it can't be performed. And when it says to explain, you would just say that there are different dimensions. D actually has multiple parts. So the first thing you would do is make sure you can do all 3 parts. They're all a 2 by 2, so you can do it. And then work 2 at a time. So the first one is addition. 2 plus 5 would be 7. 3 and negative 1 would be 2. Negative 4 and 7 would be 3. And 6 and 0 would be 6. And then from that, you're going to subtract that last matrix. So 7 minus 3 becomes 4. 2 minus 1 is 1. 3 minus a negative 2 is 5. And 6 minus 7 is negative 1. Okay, now we're going to use a scalar product. So hopefully you remember the word scalar from vectors. This just means a non-zero number. So when you're multiplying a matrix by a scalar, you're just multiplying each entry in that matrix by the scalar. This one actually says example 2, but this should be example 3. It says carry out the indicated operation or explain why it can't be performed. So this time you've got your scalar multiple on the outside. You're going to multiply that times each term on the inside. So 3 times 2 is 6. 3 times 4 is 12. 3 times negative 5 is negative 15. And 3 times 7 is 21. This last example gives you two matrices, A and B, and then you're performing different operations on those matrices. So if you look at A, it says 2 times A. So I'm going to just take 2 and multiply it in on all the different entries in A. So 2 times 3 is 6. 2 times negative 1 is negative 2. 2 times 2 is 4. And 2 times 7 is 14. Then you want to look at B, and B says 3B plus A. So 3 times B would be 15, 30, negative 6, negative 3, and then you're going to add that to A. So 15 plus 3 is 18, 30 plus negative 1 is 29, negative 6 plus 2 is negative 4, and negative 3 plus 7 is 4. And then the last one is B minus 3A. So you can either have this as B plus a negative 3A, in which you multiply a negative 3 into all of these parts and then add the 2 remaining matrices, or you can treat it as B minus 3A, in which you multiply 3 times A first, and you'd get 9, negative 3, 6, and 21. And then do B minus that. So B is 5, 10, negative 2, negative 1, minus. So individual entries would be 5 minus 9, which is negative 4. 10 minus a negative 3 becomes 10 plus 3, or 13. Negative 2 minus 6, negative 8. And negative 1 minus 21 is negative 22. Okay, that wraps up the first part of 7.5. You can use the remaining time to work on your assignment.